multiply this example 3 out, though. What I'm going to do instead is let's go ahead and let's start it like this. Okay, now if I say d dt, that's the Leibniz notation that says take the derivative. Now I'm going to go ahead and change this 1 over t to t to the negative 1 because we're going to have to differentiate it that way anyway. And then we're going to use a product rule. Okay, like that. Okay, so here's the product rule, and you got to get this memorized as fast as you can because you're going to use it all the time. So just think of this thing right here as the first function, and think of this thing right here as the second function. So if you're doing the derivative, okay, and I'll just say like derivative dt, and say that you're doing f of t times s of t, where that stands for first and second, then the product rule goes like this. It's actually very easy to remember. What you do is it's just the first multiplied by the derivative of the second, which we're going to represent just as an s prime. Then we do it backwards, plus the second, and then times the derivative of the first. Okay, like that. So that's what we're going to utilize in this, is we're going to utilize that formula then. Okay, do I need to dim the lights or anything? Will that help, or can you see it okay? Are we okay? Okay, all right, okay. So let's go ahead and start on this. So what you actually do when you do the derivative, just write down the first. Don't touch it, just write it down. Okay, leave it alone too. Just t plus t to the negative 1, like that. Then I'm going to have you go ahead and write this down. I want to kind of get you in the habit of doing this. Just write d dt because you're going to take the derivative of the second. I really like you to write this step before you do the derivative. Just get it set up. Now what you're going to do is you're going to write the second. You're not going to touch the second. You're just going to write it down. And then we're going to multiply by the derivative of the first, based on the power rule and stuff that we were working on last week then. Okay, so all I've done so far is I got it set up in the product rule. Okay, like that. So what we're going to end up doing now is the next thing that you need to go ahead and do is you just do these derivatives. You do that derivative, you do that derivative, and then after you've done that, it becomes an exercise primarily in just doing algebra, okay? And these two derivatives that I highlighted, you do in your head now. You don't have to do this limit thing. So this is just going to be t plus t to the negative 1, okay? Now, what is the derivative of what I highlighted there? 2t minus 3. Okay, remember that's power rule, so the 2 comes down. The derivative of 3t is the number in front. That's called a linear term. Okay, and then what's the derivative of 5? 0, because it's a constant. Okay, so you got to get those rules down. So this is going to be 2t here minus 3, like that. Okay, so that's what that derivative is. Now proceed on. Write the second. The second is t squared minus 3t plus 5. Now let's see if we can do the derivative of this. Okay, one at a time. What's the derivative of t?
1.
1. It's the number in front. Okay, how about this? Negative 1 t to the negative 1 minus 1, right? By the power rule. So that's going to be, and just write minus 1 t to the negative 2. Like that. You can leave the minus 1 off, of course, but that's it. So right there, the calculus is done. Calculus has been accomplished. We've got a derivative. What we need to do is we need to clean it up a little bit. And a lot of times on these problems, we don't really do much with them. So what I would suggest that we go ahead and do on this is let's just multiply it out. Okay? Now, like this is going to be a FOIL problem there that we're going to do. And then we're going to multiply this out like this. So it's a good idea to just start multiplying it out. Now you're just going strictly to your algebra background, say, okay? So let's kind of do this. So that first term is going to be 2t to the second. That outside term is going to be minus 3t. Now this is kind of stuff you get into. What is that going to be? It's really, if you think about that, if you're doing that, you're doing t to the negative 1 times 2t to the first. Isn't that just 2t to the 0? Because you add exponents, right? Okay. If you multiply, you add exponents. Well, what's t to the 0? It's 2. It's 1, so 2 times 1 is 2. Okay, like that. So you're going to do that. A lot of times I see students have issues with exponents and background issues in algebra. So that piece right there is 2t to the 0, but it's 2 times 1. Does that make sense to everybody? Okay, all right.
Like then, 2 to the 0 is on the bottom all the way. Yeah.
Well, right here, when I'm doing this times this, I'm adding the exponents, right? So I'm doing t to the 2t to the 0, but t to the 0, anything to 0 is 1, so that's why that's just 2. Okay, that's what that middle term is it's 2t to the 0, so it's 2. Add exponents when you multiply. Okay, then this last term right here is minus 3t to the negative 1, and just leave it alone. Okay, all right. So you got to know your exponents and know them well. Okay, now let's go to this. T squared times 1 is plus t to the second. Okay, now we can take t squared times negative 2t to the negative 2. And with practice, you'll get to where you do this in your head. Okay, I'm doing t to the second times negative 1t to the negative 2. So what is that? That's negative 1t to the 0, so what is it? It's negative 1. So it's the same situation, see? Okay, when you multiply variables, you add their exponents. Now you do this. Negative 3t times 1 is negative 3t. Okay, here's this thing again. Now that's negative 3 times negative 1 is positive 3. Then see, this is a t to the first. So 1 plus negative 2 is what? Negative 1. Okay, you're doing arithmetic. Okay, I'll do the 5. 5 times 1 is 5, so that's easy enough. And then 5 times negative 1 is negative 5t to the negative 2. Okay? Now that's foiling and multiplying. You guys have done that fine, but you've got to be sure that you pay attention to those exponent rules when they show up. Now, do you see any like terms that could go together? So let's just start putting them together, and then we'll write out all of the, change the negative exponents to positive primarily. Then we'll be done then. Okay, so let's put this together then and see if we can get an answer then. Okay, so we have the t to the seconds go together. It doesn't really matter what order you put this in. I'm going to work with the highest exponent, so that's 3t to the second. That'll take care of that. If we go to the t's, it looks like we have 3t and negative 3t, and that's it, so that's minus 6t. Okay, so that puts that together. What else we got? 2 plus 5 is 7. So those go together.
Minus 1.
Do I have something, what?
Minus 1.
Oh, I didn't see the minus 1, thank you. Okay, so that would be 7 minus 1 would be, what, plus 6. Okay, and then these go together. These cancel right here. If you look at these two terms right here, they cancel. So it looks like we are left with a minus 5t to the negative 2. Okay, and it doesn't matter what order you write this in, so I'm just going to write this as 3t to the second minus 6t plus 6. And then how do you write the last term? 5 over t squared, right? Okay, you make that a positive exponent, so you say 5 over t to the second, and then that would be your derivative, okay? Okay, that's the easy way to do it. If you did this problem by this quotient, this limit definition, it'd be really rough, wouldn't it? Okay, so that's part of what we're doing is all these rules we learned are technically they're simplifying what we do. Now, tell me, what's the hardest part of that problem, the calculus or the algebra? Algebra. That's generally what you find in here. Mostly it's algebra issues, but you will get better at it as time goes on, okay? All right, is there any questions about anything on that I did, any of the algebra or anything? Because now we are going to get into I think the quotient rule on the next page here.
Is there a, if I dim the lights, just a little bit extra?
Is there a what?
Is there if I dim the lights, just a little bit extra?
Yeah, you can. Let's just bring some of the shades up just a little bit so I can see your smiling face, if you don't mind. Okay, so we're going to do a little bit more with the product rule. I guess I'm going to do one more example of the product rule. Yeah, that's the only light in here. Just switch it off. Then we'll be okay. Can you guys raise the shades just a little bit so I can see a little bit, because I can't see very good if those shades are down. So bring them up a little bit more. Okay, so on this next page on example 4, let's go ahead and let's just multiply this out. Now, as a calculus student, to me, now you can write that out twice in FOIL, but to me, it's pretty important to just learn to do squaring something in your head. Okay, all you do is you just square the first term in your head. So 4x times 4x is 16x the second. Then you square negative 5. Negative 5 times negative 5 is plus 25. Then you have a middle term. The middle term comes from doing this. You take 4x times negative 5, which is negative 20x, but then you double it. So that's going to be minus 40x like that. You'll save yourself a lot of time if you can just get in the habit of squaring binomials in your head. Okay? Now we're going to do the derivative, so let's just do the Leibniz notation. We'll say dy over dx, which means take the derivative of y with respect to x. You can do this in your head. What's the derivative of this problem? 32x minus 40. That's it, right? Remember, the derivative of 25 is a constant term, so it's equal to 0. Derivative done. Okay? So it's a line. Okay? Now, the function you did was a quadratic, so what happened? The derivative went down 1 power, it became linear. That's what happens on polynomials is the power goes down 1. Okay, now let's do the product rule. Now the product rule, again, just kind of think of it as first times derivative of second plus second times derivative of first. Okay, so we're not going to multiply it out, so we're just going to do this like this. Okay, so first of all, the first is just going to be 4x minus 5. Because what you're really doing, if you're doing the product rule, is you're just thinking of the same thing twice. Okay? All right, so the first is 4x minus 5. Okay? Then we're going to multiply by the derivative of the second. This time, let's just do this in our head. What is the derivative of 4x minus 5?
4.
That's 4, right? Okay, so that's 4. Now, write the second. The second is 4x minus 5. What is the derivative of the first here? 4 again. Okay, you guys see what I did? Okay. Now, you can multiply it out, or you can even do this. So well, let's multiply it out. I think that's what you'll see best. So that would be 16x minus 20 plus 16x minus 20 again. Add the like terms, you're going to get exactly the same answer. So that's 32x and then minus 40. Now, to me, personally, I find it just as easy to do this problem the first way. What do you think? It doesn't make any difference. Partially what I'm trying to do is just show you that the product rule is going to work just as well. But there's going to be plenty of times, like the last problem is a pretty good example to me that it's just as easy to do the product rule on. Okay? All right. So next thing we're going to begin to look at is what we call the quotient rule. So I'm going to use this example to demonstrate the quotient rule. I'm not going to prove the quotient rule. But there's 2 ways you could do this. The first thing I want to look at is, does it work if we just took the derivative top and bottom separately? Okay? So first of all, let's do this like this. Let's just go ahead and simplify this. So if you have x to the 5th over x to the 3rd, what do you do with the exponents if it's a fraction? You subtract, right? So what is x to the 5th over x to the 3rd? It's x to the 2nd. Okay, now what is the derivative of x to the 2nd? 2x. So that's the derivative of that function, is definitely that. So what I want to see is what would happen if we did the derivative of the top and the derivative of the bottom separately, and let's see if we get the same answer or not. Okay, this is a real important connection to make. So what's the derivative of x to the 5th in your head? 5x to the 4th. Okay, what's the derivative of x to the 3rd? 3x to the 2nd. Okay, what is x to the 4th over x to the 2nd? X to the 2nd. Okay, did we get the same answer? No. Okay, so it doesn't work. Okay, so if you have a quotient, you can't just do the derivative of top, derivative of bottom, divide. It doesn't work. Okay, it may work in a few situations, but in most situations you have to do what's called the quotient rule. So that's what I'm going to show you next, is we're going to work a little bit on what we call the quotient rule. Okay? Okay, so let me move this down just a tad bit here. So here is the quotient rule. Okay, this is the other rule that you got to try to remember. Okay, and after time, believe me, when you're doing your homework, you'll probably have to review it and refer to it. but over time you'll get it memorized because you'll use it so much. So what you do is if you have a derivative of two functions, f of x is the top of the fraction, g of x is the bottom, what you do is you do the bottom times the derivative of top minus top times derivative bottom all over the bottom squared. Okay, that's just the way the proof turned out. You actually proved this by putting this in the limit formula, limit of f of x plus h minus f of x over h, and this is what pops out. Okay, so learn it in words. The way to learn this in words is bottom times derivative of top minus top times derivative bottom over the bottom squared. Okay, that's how a quotient rule works. So anytime you have a function that is a fraction, that's the way you have to differentiate that. Okay, so we'll work a little bit with this on the next page. And this is another way that I've seen. I don't usually teach it this way, but sometimes students remember it better this way. This confuses me more than it helps, but you could say low-d high less high-d low over low-low. Okay, so what that says is you're doing the bottom, which is the low, times the derivative of the top, which is high. So you're saying low d high, d standing for derivative. Then you're doing minus or less. Then it's the top times derivative bottom, so it's high d low. Then it's over low low, which is the bottom square. So you could say low d high minus high d low over low low. You could even make a rap out of that if you wanted to. Okay, so whatever sticks in your head, I don't care, just you got to know it. Okay, now this is the proof basically, and I mainly just put that on there for you to review. I'm not going to go over that, but that is a good thing for a student to go through and look at. It's really not that hard of a proof, because the thing that is required on this proof, though, and this is kind of what you get into, mathematicians just have to be really clever sometimes. And the key part of this proof is this. Now, when I put this in the difference quotient, like we learned, you would end up having that. But notice what we did is we subtracted and added the same quantity. And then if you go through and look at that on your own, it's not that hard to follow. But I don't have you guys do a proof of that or anything, but I do like to at least give you an idea where they come from. Okay? So that's a good thing to study, particularly if you're like going to study math one day, like me, and be a math major, because this kind of stuff you start learning how to do is prove everything. Okay? All right, so let's do the same example that we did earlier. Now let's do this example with the quotient rule now, and just kind of go over that. Okay, so first of all, same example, if you have y equals x to the fifth over x to the third, well, we know algebraically that's x to the second. Okay, this is the easy way to do this problem. So what is the derivative of x to the second?
2x.
2x. Okay, that's the answer without a doubt. Okay, now the quotient rule, the way I remember, it's like this. Bottom times derivative of top minus top times derivative of bottom over bottom squared, like that. So we're going to do this the same way. So we're going to go through and take this function, and I'll do it with the quotient rule, and we're going to get the right answer if we do the quotient rule. So here's how you would do this using the quotient rule. What you do is you write down the bottom, and you don't touch it. You just write it down. Okay. Then what you do is you take the derivative of the top, which we'll do in a minute. Then we do it backwards. Then we write down the top, don't touch it. Then we do the derivative of the bottom. And that's going to be all over the bottom, whatever it is, squared. Okay, so let me pause there for a minute, make sure you got that down and see what I'm doing. So again, it's just write down bottom, derivative times derivative top, minus top times derivative bottom over bottom squared. Does that look okay? Okay. Now let's put this together and see what comes out of this. Okay, this is x to the third. Now what you guys need to do is you need to do these two derivatives, and then we'll clean it up and see what happens. So we need to do that, and you need to go ahead and do that, and then it's just a matter of algebraically simplifying. So what's the derivative of x to the fifth? 5x to the fourth. And what's the derivative of x to the third? 3x to the second. What's the value of the bottom? X to the sixth. Okay, you got to know the rule that says x to the m to the n That's when you multiply exponents. You got to know that. You got to know these exponent rules because they're going to keep popping up. Now, if we algebraically simplify this, what is this thing right here that I just circled? 5x to what power? 7th. Good. Okay, what is this? 3x to the 7th, right? All over x to the 6th. Those are like terms in the numerator, so we get 2x to the 7th over x to the 6th. Look what happens. You subtract that exponents, don't you get 2x? Okay? Obviously, the first way is the easy way, but there are many instances where you have no choice but to apply the quotient rule. So that's a demonstration of how it works. That's not a proof. That just demonstrates that it would work. Okay? And it always does. Okay? It always works. The only time it doesn't work is if the bottom is 0. And of course, you can't have a denominator that's 0 anyway. Okay, how's that look to everybody as a starting example for quotient rule? Okay, all right. Work on those exponent rules. That's the big deal that happens in this stuff quite a bit then, okay? All right? Everybody got that? Okay. Okay, now, these are kind of typical on the next page, typical quotient rule examples. So the way we got to do this is when we do dy over dx, you want to go ahead, and you'll see me use Leibniz notation. I just think it's a better notational system when you're using the quotient rule and the product rule. So what you do is you start by writing the bottom. Don't touch it, just write it. Then write down that you're going to do the derivative of the top. Now certainly you can do that in your head. I do like students to write their first step this way because it emphasizes the notational system. Now write down the top, which is x to the 3rd plus 27, and multiply that by the derivative of the bottom, like that, and then make a big fraction bar, and it's going to be all over the bottom squared, like that. So you want to get that written down, and then it's a matter of just going through doing the derivatives. Usually students don't really have much trouble doing the calculus part. The part, again, becomes how good are you with your algebra. So we need to, in our next step, we need to do this derivative and that derivative, which are, you need to get to a point, if you're not already there, that those two derivatives are pretty easy for you, okay? So let's go ahead and I'll just bring this over here. So this is x plus 3. What's the derivative of this thing in your head? Okay, 3x to the 2nd. Okay, so we do that. Okay, then we have minus x to the 3rd plus 27. And what's the derivative of x plus 3? 1. That's the one that students a lot of times forget. Remember, that's y equals x plus 3. Isn't that just a line? What is the slope of this line? 1. Okay, that's y. Okay, that's a linear function, so its derivative is the slope. Okay, now, one thing that's real important on this, don't take the time, I can't think of any situation where you would ever want to multiply that denominator out. Just leave it alone. Because what happens is, a lot of times you have cancellations, and you want to do cancellations by factoring. So really what we do in this is just multiply this out. Now it's the algebra time. So we do 3x squared times x, which is going to be 3x to the 3rd. Then we do 3x to the 2nd times 3, which is going to be plus 9x to the 2nd. And be careful with your sign on this. If you multiply that by 1, nothing's going to change. But what is that minus sign going to do there? It's going to distribute and change that to minus x to the 3rd minus 27 all over x plus 3 to the 2nd, like that. Okay, so be careful about stuff like that. That'll show up constantly. You have minus in front of parentheses, distribute it through. Okay, the only other thing you can really do is just collect the like terms. So that would be 2x to the 3rd plus 9x to the 2nd minus 27. And then just leave the denominator factored. You don't need to multiply that out. There's absolutely no need to ever do that. So that would be the solution of the problem right there. Okay? That would be another example of a problem. If you did that with limit definition, it'd be like 10 times more complicated than this thing on the board. It'd be a mess. Even though there's a lot of algebra going on in this, it does significantly simplify what you did. Okay, so that's not too bad of a starting example. You guys follow that reasonably well? Okay, so if you know the derivative rules in your head, that doesn't have too bad of algebra involved in it, but sometimes you're going to get into that. Okay, so let's do this next one. And again, this is a prime example of the quotient rule because you have a quotient of two, you have a fraction, you have a top and bottom. Now, if I say d dt of something, that means that I'm asking you to do what? I'm asking you to do the derivative. The reason it says d dt, and this is a mistake, by the way, do you guys know what my mistake is? It needs to say this. You guys, I have a terrible time doing this because I like to change variables when I type these things up. This is what it should be, is you need to rewrite it like this, just because variables can be anything, but just to give you the practice with the notational system. So that's what it really should say is this. Okay? All right, so we're going to go ahead, and what we're going to do is we're going to put this in the quotient rule. Okay, so let's go ahead and start that. So what you're going to do is you're going to, go ahead.
You'll want the bottom to include the -2 in the...
Oh, is the whole thing
Yeah.
under a radical? I wonder if I meant that. I don't think I meant that, actually. It's okay, but no, actually you guys need to change that to square root of t minus 2 because I haven't taught you what's called the chain rule yet. And it would be have a chain rule piece in it. That was a misprint. I typed that wrong also. So the square root is only, the t is the only thing under the square root. So write it that way, okay? All right, so here's how it goes. Again, it goes like this. Bottom times derivative of top. Whoops, not like that. Bottom times derivative of top minus top times derivative of bottom squared. You don't need to write that down. I'm just putting that on there to refer to. So go ahead and start. Write down the bottom. Don't touch it. Then we're going to multiply by the derivative of the top. Now, I would recommend, what do you have to do if you're going to take a derivative of a square root anyway? You got to change it to a 1/2 power. So I'd recommend that you just go ahead now and change that to t to the 1/2 plus 4 like that. Now minus, now it's the top, so don't touch it. You can go ahead and change these to 1/2 powers all now if you want to. Then multiply by the derivative of the bottom, and we're going to write that as t to the 1/2 minus 2, and then it's going to be all over the bottom squared like that. Okay, this one may have a little bit more difficult algebra in it just because of the square roots, but that's the only thing that's going to make it a little bit more challenging. Okay, now we're going to go ahead. The next thing that we need to go ahead and do is, focus on doing these derivatives. So you need to go ahead and do that. You need to go ahead and do that. Okay, and we've worked on certainly that kind of situation before. Okay, now I'm going to go ahead and just change all these things. So this thing, let's write that as t to the 1/2 minus 2 because we're probably going to have to multiply stuff out anyway. Okay, in your head, what is the derivative of this thing I'm circling?
1/2 t to the -3.
Good. 1/2 t, 1/2 minus 1, but use 2/2 for 1, right? Bring down the exponent. Remember, it's bring down the exponent, subtract 1. So that's going to be 1/2 t to the -1/2, like that. You're going to have to just deal with the fraction arithmetic. Okay, now let's go to this next part and write this as t to the 1/2 plus 4, and then let's do this derivative. This derivative right here is exactly the same thing. Bring the 1/2 down, subtract from the exponent, you're going to again get times 1/2 t to the -1/2, like that. Then it's all over the bottom squared. Don't take the time to multiply the bottom squared out. Just leave it alone. Okay, because it's something may cancel at the end like that. That's calculus. Calculus is now done.
Wait, now, so on the first term, so d times t or whatever on the very left side, isn't that supposed to be 1/2 t to the -1/2 minus or plus 4?
No, because the derivative of,
okay.
that's a constant, so the derivative of 4 is 0, just like the derivative of 2 is 0. Those are constants, okay? All right, so now what we're going to do is we're going to multiply this out. So we got to just do a distributive property. So if we take this times this, we're going to get 1/2 t to what power? If you take a half and add -1/2, don't you get 0? So let's write it that way, okay? Then let's do this. That will be minus 2 times 1/2. Now I'm going to go ahead and just write it out. I'm going to say 2 times 1/2 t to the negative 1/2 like that. That takes care of that distributing property. Now I'm going to take this times this. So that's 1/2 t to the 0 again. It is a minus. So that's going to be minus 1/2 t to the 0. Okay, again, I'm taking this times this. You guys see it okay? Then I'm taking this times this. Now that is a minus now. That minus distributes through, really making that a minus 4. So that's going to be minus 4 times 1/2 t to the negative 1/2. And then that's going to be all over the bottom squared again like that. Okay, so that's how that goes like that. This is the part of the problem that students usually struggle with a little bit until you get a little bit more practice with it. Okay? Now, what is the value of these things right here that I'm highlighting?
1.
That's 1, right? Okay, so it's going to show up. So anything to 0 power is 1. So like I said, you got to be totally solid with all these exponent rules. So this thing right here is 1/2 times 1, so that's a half. Okay? If you look at this piece right here, the 2's are going to cross out, so you're going to get minus t to the negative 1/2. Okay? This piece right here, again, that's going to be minus 1/2. Again, t to the 0 is 1, so that's going to be a half times 1. Then this part over here, 4 over 2 is 2, so that's going to be minus 2 t to the negative 1/2. And then again, it's all over the bottom square. So square root of t minus 2, second power. Guys, that look okay? Okay, now do you see cancellations in like terms?
Yeah.
That's what you do. Okay, so the next thing we need to do is just kind of put all this stuff together here to get the answer. That 1/2's cross out. This is minus 1 minus 2, so that's minus 3t to the negative 1/2, all over square root of t minus 2 squared. Now, what I would like you to do on this problem is take it all the way to the very end. Students always in calculus say, but do I have to? My answer is yes, you have to. Okay, because it's the only way you're going to get better at your algebra. So, there's a couple of things that you want to do. Bring this thing down to the bottom. It's got a negative exponent. Bring it down and put it in front of that denominator. So that's going to be t to the negative 1/2, or actually it'd be positive 1/2 now, times square root of t minus 2 to the second. And then the other thing I'd like you to do is just change that to a square root. So you'd have negative 3 over square root of t times square root of t minus 2 to the second. Now you're done. That's a beautiful answer right there. Got radicals. We see the problem started with radicals and it ended with radicals. And if we were doing stuff like crunching out a slope of a tangent line, finding an equation of a tangent line, finding minimums and maximums like we do later in the semester, then you want it in that form. Okay? So, what's the hardest part of the problem? Not the calculus, the algebra. That's what you got to get solid with. Okay? Do you guys follow or have any questions on any of the algebra or calculus part? Okay. All right.
Wait, so I was going to ask, like, so right here,
Uh-huh.
like right there, so why does the 4 not disappear on those?
Well, that was cool. Do that again.
Yeah, I was
I
playing
was
with my
like, does my pen do it? No, that's great. I like that.
I'm glad, because I was playing with my dog with this
That's
one.
very cool. So what part is that?
So it's right here.
Okay.
And then right here, how
Okay.
the minus 2 and the plus 4 don't disappear on the derivatives for those for.
Well, those were your question, I think, was, yeah, right in here. Those, when you're doing the derivative of this thing here, this is 1/2 t to the negative 1/2, but that's 0.
Right.
Constant of 4 is 0, so that's why there is no 4 there, because that derivative was 0. Same thing here. That's power rule, so that's 1/2 t to the negative 1/2, but that's 0. That's why it's gone.
Well, right, but then on the first term and then on the first inside term as well, like where there's plus 4 and minus 4.
Okay, that's because the quotient rule said bottom times derivative of top. I just write the bottom. I don't do anything with it.
Okay.
See, that's the idea. Okay?
So,
All right.
so it's bottom and then derivative.
Derivative top minus
then-
top times derivative bottom over bottom squared.
Okay.
So that when you're writing down the bottom and top, you're not changing it.
Okay.
Okay, that stays the same, so that's good. Okay? Okay, so let's do one more of these and see if we can put this together now. Okay? So let's see. Let's go ahead and start it together, then I'll give you a little bit of time to see if you can finish it. The only way you're going to get good at this stuff is just to crunch it out and practice it. Okay, so when we do this, dy over dt, dx, or no, dt, because t is the variable. Okay, what you do is you start by writing down the bottom. Don't touch it, just write it down. Now that's what you were kind of asking about there is, okay, you don't touch it, okay? Now what you're going to do is you're going to multiply by the derivative of the top. I do like you guys to write it down this way before you do that derivative, even though obviously you can do that in your head. Now it's minus the top. Again, don't touch it. Then we're going to multiply by the derivative of the bottom. Okay, like this. And then you want to go ahead and write the bottom squared. Now you're not going to do anything with the bottom squared, you just leave it alone. Okay, so I want you guys to go ahead and just work on that for a few minutes and see where you get, okay? It's an easy problem to mess up on just because there's lots of terms and lots of signs. Okay, just keep going on it, and then you can look up here and see if you're anywhere where I am. Anybody getting a 14t squared? All right, okay, all right, that's good. And let's see, for the t's, 14, 12, 4t. Okay.
Plus 6.
Okay. Plus 6.
Wait, what'd you get for the middle term?
4t. Because I have 6 plus 8 looks like it's 14. Minus 2 is 12. Minus 8 is 4, so 4t. It's an exercise in algebra and multiply and everything else, so that's what I got. Assuming I didn't make any arithmetic errors, that's what I have. So I think one thing that you need to kind of look at on your paper, like the second stage, that's the calculus, so you wanted to be sure that you did the derivatives okay. And then what you want to make sure is you did the multiplication out okay. Now, I think the thing that happens a lot of times to students on problems like this is, so you have that minus sign in the quotient rule. So when you multiply this out, you want to be sure that you change all those signs. And that just becomes an exercise of multiplying and then collecting like terms. Do you get the gist of what I'm doing okay?
Yeah.
Okay. I mean, you got to just be careful, very careful in what you do on a problem like that. You have to. Okay. Okay. Anybody else get that same answer? Okay. You got it? You got it? Okay. That's good.
How come we don't do anything to the denominator?
So is there any questions about that? Yeah, go ahead.
How come we don't do anything to the denominator?
How come I what?
How come we don't do anything to the denominator?
Well, the quotient rule says bottom square. And the reason you don't want to take the time to multiply that out is because sometimes, not always, but sometimes you can factor the numerator and cancel it with that. Now in this case, you could pull a common factor of 2 out of the numerator if you wanted to, but it wouldn't cancel anything down there. So for that reason, you never want to multiply that bottom out. Leave it alone. Just always do nothing with it, okay? Because you're going to have that cancellation. Okay, well, let's do a tangent line, and then I want to finish up with one more rule to show you. And the key thing on that one is just make sure that you had the signs correct. I'll move this up a little bit, and then you can get that copy down if you still need to, okay? So with this next problem, we're going to find an equation of a tangent line to this function, and then I gave you a point, okay? So whenever you're dealing with a tangent line, if I want you to do a tangent line, we've done this several times, and we're going to keep doing it. It's y minus y1 equals, and then instead of doing m, you do the derivative at the x value that I give you. Okay, because that's what it is. You're used to that being m, but now that you're a calculus student, then the derivative of that function at x equals -2 is the slope of that tangent line. Then you do x minus x1 like that. So the big part of this problem is doing the derivative. Okay, so this is going to end up being, again, a quotient rule that you're going to have to do. Okay, now I'm going to move this up here a little bit, but I'll still leave that up like this. So I'm going to do the quotient rule just kind of at the side here. So let's go ahead and get this set up. Okay, so we're going to do f prime of x. Then we're going to evaluate that at -1. Okay, now this time we can save a little bit of work if you want to. You can just say, okay, let's write down the bottom. Okay, now let's do this in our head. Okay, what is the derivative of the top, x squared plus 3? 2x, right? Just write it down. If you want to save a little bit of time, you can do that if you want to. Minus the top. Don't touch it, just write it. The top. Okay, now what is the derivative of the bottom, x minus 1? That's 1, so that's kind of nice. Okay, that's pretty simple. Okay, and then it's all over, what do you do at the bottom? You square it. Okay, so it's all over the bottom square. So that's the quotient rule that's set up. Now what we need to do is we need to multiply it out. So this is going to be 2x times x is 2x the second minus 2x. Now if you take this and multiply it by 1, nothing's going to happen, but that minus sign is going to change this to what? Minus x squared minus 3. Be careful about that. And you got the bottom squared. Okay, like that. You do have like terms, so 2x squared minus x squared is x squared. Then you have minus 2x minus 3 all over x minus 1 to the second, okay? Now, it may be that that may factor, well, yeah, 3 and 1, that might factor. We can try to factor it, but it might not do any good. But it looks like that numerator, you could go x and x, 3 and 1, with a minus 3 and a plus 1 to factor that. Now, the reason I wanted to go ahead and do that is just to mention that sometimes, you know, someone asks, why do we leave that alone? Because what if that was an x minus 1? Then we could cancel, right? So the thing is, you never want to multiply the bottom out because you can simplify it sometimes. Okay, so that's what the derivative is. Now, what we need to do is, we're interested in this point right here. So x is negative 1. So now you need to plug negative 1 into this to find the slope of the tangent line. So the quotient rule gave us the derivative. So now we're going to do f prime of negative 1. Well, let's just plug it into the factored form, or it's up to you which form you plug it into. It doesn't matter. So this is going to be negative 1 minus 3 times negative 1 plus 1. Oh, this is going to be really cool. So that's negative 1 minus 1 to the second. That is negative 4 times 0 over negative 2 to the second. What's the answer? 0. Because the numerator is 0, right? Okay, so that means the slope of the tangent line is going to be 0. If that happens, you like it, because it makes everything a lot simpler. So this is your derivative right here. Okay, and then when we plug in negative 1, because that's the point I'm interested in, turned out that this part right here turned out to be 0, so that means the slope of the tangent line is 0. Okay, does that make sense? Okay, all right, yes, no? Tell me. Okay, all right. Now, plug into this formula. So negative 2 goes here, 0 goes there, and, whoops, putting that, yeah, negative 1 goes there like that. Okay, so we're going to have y minus negative 2 equals 0 times x minus negative 1. So that's going to be y plus 2 equals, and then this whole thing's 0. So you get y equals negative 2. So what kind of line is that? If you graph it, what's going to happen? You're going to get that kind of line, okay? All right. Now, what I'd like you all to go ahead and do is put this in your graphing calculator, the original. So if you got your graphing calculator, put it in your graphing calculator like this, and I'll display my calculator in just a minute. Just put in x squared plus 3 divided by x minus 1, and graph it in the standard window. And then also in y2, graph out, and let's see, our equation of tangent line is negative 2, so put those two things in, and then we'll take a look at it and see what we get then, okay? So put those two things in and see if it makes any sense to you. Just do the zoom standard, and then I'll go ahead and I'll display my calculator up here so you can kind of see what I'm doing here. Can I see your handout for just a second? I don't know what the function is. Okay, I can't see. Okay, so let's see. Let's put in, where am I at here? X to the second plus 3. And then divide by, what was it? X minus 1. Okay, then we'll put in negative 2. Okay, now what I can do on this is I can just go zoom 6. That way I'll automatically put it in a standard window. Okay, there's your function. There's your tangent line. Does that look like a tangent line? That's beautiful. It's a thing of beauty. Now look at this. If you trace at negative 1, that's the point we were looking at, negative 1, negative 2. So it's real easy to interpret that that's like a maximum. That's a place where the tangent line has a slope of 0. So that right there visually should sum up and help you make sense of the problem. Okay, is that sensible or not? Okay? Graphing calculators are good tools to help you understand what goes on in these problems. Okay? All right, well, let's go ahead now. Let's just take like about a 10-minute break, and then I'm going to teach you one more rule on this, and then the next part of class we're going to start working with the trigonometry part of calculus a little bit today as well. Okay? So this is a real simple derivative rule. The textbook sort of puts this in kind of a funny place because what we'll be working on next will be something we call the chain rule. But what this is saying is the one thing we learned is we learned this. This is actually the easiest derivative rule of all. We learned that the derivative of e to the x is e to the x. It's the same. Okay, that's how that goes. That's a basic rule that you want to remember. Now what this is saying is if you have derivative of e to the kx, where you put a number in front, then it's just ke to the kx like this. So an example of this would be like if you did the derivative of e to the 10x, the answer is itself, but it's really that k, that part right there comes down in front like this. I'll explain why that is when we get to the chain rule. To me, this is a little bit of a strange place to even put this in a textbook because it's not necessary, because the chain rule is going to explain this anyway. So it's a real simple thing. It is nice to just get this, though, in your head where you can do this real fast. So if I was doing the derivative of e to the 100x, well, what is that? It's itself, and then you put that 100 in front like that. So that's how it goes. It's a very easy derivative rule to remember. So we're going to work a little bit with this then. Okay, so this example one, we're going to do the derivative of this function. So first of all, you have a constant times this. Okay, so what you do when you do this derivative, if you have a constant times something, you bring the constant down. Don't do anything with that. A lot of times students want to do a product rule on this by thinking of the first is 9 and the second is e to the 3x. Well, it would work out okay if you did the product rule. It's just unnecessary. The first term's a constant, just write it down. Now do the derivative. Just multiply that by the derivative of e to the 3x. Okay, now put it together. So what is the derivative now of e to the 3x in your head? 3e to the 3x. Good. Okay, like that. So that means now the final answer to this problem, 9 times 3 is 27. So that's going to be 27e to the 3x. Okay, so that's what that is. Okay, so if you have a constant, write it down, multiply by the derivative of whatever that function is. Okay, product rule would work, but it's unnecessary. Okay, okay, this is basically the same way. Now this one, I'm going to write this as, I kind of like to write this as 2e to the 1/2 t. Okay, a lot of times I'll see students in this class, they kind of forget that t over 2 is the same thing as 1/2 t. It's advantageous to write it that way if you're dealing with a derivative. So you're going to do this exactly the same way. You're going to write down the constant 2 like that. Then you're going to multiply that by the derivative of e to the 1/2 t. Just write the constant down. Don't touch it, write it down. Okay, so what is the derivative in your head of e to the 1/2 t? 1/2 e to the 1/2 t. Okay, good. Okay. What you're going to learn a little bit later is what you do is a derivative of an exponential is just itself, but then you do the derivative of the exponent. The derivative of the exponent is 1/2. Now the 2's cross out, so you would get an answer of e to the 1/2 t, which you can write that way, or you can write it back as e to the t over 2 if you want to. Like that. That'd probably be the best way to write that. Okay? All right. So that is a derivative rule for an exponential when you have a number in front of x. And that's how you handle that kind of thing. Okay? All right. Does that look okay to everybody? It's a little easier than what we've been doing, isn't it? Okay. The exponentials are the easiest derivatives to learn. Now this one, what kind of rule do you have to use? You have to use quotient rule. It's a quotient. Okay, so the derivative, remember, on a quotient rule is bottom, and you don't have to write this down. I'm just going to write this on here so we can refer to it. It's bottom times derivative of top minus top times derivative of bottom over bottom squared. Okay, like that. All All right, so when we do this derivative, let's put this together. Write down the bottom and don't touch it. So that's e to the 5x. Multiply by the derivative of the top minus the top. Again, don't touch it. Times the derivative of the bottom. And it's going to be all over the bottom, e to the 5x to the second power. Like that. So there are going to be a few algebra issues that are going to pop up in this now that you want to kind of be aware of. Okay? All right, now let's do the derivatives. So what we've done is we set up the quotient rule. Now we need to do these two derivatives that I highlighted, and then what we need to do is do whatever cleaning up we can do. Okay, so what's the derivative of 2x? 2. So this is going to be e to the 5x times 2. Then we have minus 2x. What's going to be the derivative of e to the 5x? 5e to the 5x. Good. Okay, so we write that down as 5e to the 5x. What do you think the bottom's going to be? I want you to square that out. In this case, it's not a binomial squared. So just, what's it going to be, you think? I'm asking this because students a lot of times ask this question. It's e to the 10x. Okay? See, the thing that you got to remember is if you have, like, for example, if you had x to the third to the fourth, what do you do with the exponents in that case? You multiply them. So that's what you're doing is you're doing 5x times 2. So you can think of this one of two ways. You're applying that multiplication rule, so it's e to the 10x, or you could write it out times itself. So don't you just add the exponents if you multiply it like that? So 5x and 5x is 10x. So that's going to be e to the 10x when you multiply it out. You want to go ahead and multiply it out in that case. So now if we put this together, we're going to have, and there's not going to be much we can do this other than factor, so I'm going to have you do two things. We're going to write this as 2e to the 5x. It's best to put the 2 in front. Then we can do 5 times 2 is 10x e to the 5x all over e to the 10x like that. Okay, now I would like you can stop there if you want to. I mean, that's a okay answer for that derivative. But you want to start getting in the habit of factoring. So I want to talk about that a little bit. So what do you see in the numerator that's a common factor? E to the 5x is, and how about between 2 and 10? 2. So you want to take a 2e to the 5x out and then write what's left. And then it will be all over e to the 10x like this. Okay, so this is going to be 1 there because 2e to the 5x times 1 gives this term, minus 5 times x. Verify that yourself. 2 times 5 is 10, and you have the x, and you have e to the 5x like that. Okay, that would also be an okay answer, but there is one other thing you could do to that problem. What do you think? You could simplify those e to the x's, couldn't you? Okay. Remember, if you have something like, if you had like x to the 5th over x to the 10th, what do? You subtract the exponents. So that would really be x to the negative 5, then you could make the exponent positive. So what you would do when you put these two things together, this is what you would have. I'm kind of running out of room here, but you can kind of write this on here. When you put that together, what you would actually have is you would have 2 here. Now, if you subtract the exponents on 5x and 10x, what do you get? You get negative 5x. So that would be 2e to the negative 5x times 1 minus 5x. And then what could you do with that negative exponent? You take it to the bottom. So the best answer, the actual simplified answer to this is 2 times 1 minus 5x all over e to the 5x like that. You want to go that far? Yes, you want to go that far. You need to. Okay, so you're going to do a lot of factoring in these expressions, and the factoring may look a little bit different to you. Okay, but it's the same concepts you learned when you did common factors. Okay, so generally on this, it's not the calculus part that's a little challenging for students, it's the algebraic simplification. So is there any questions about any of that algebraic simplification, the factoring or the reducing or anything? Does that look okay to everybody? Okay. All right. Now that's kind of a couple of examples of how you would use that particular derivative rule. So what I want to look at on page 9, and then I'm going to do something pretty similar on page 10, is just go ahead and look at when you combine rules with this, and then I'll just do an example of like a second derivative, okay? So what kind of rule would you use on example 1? It's quotient rule. Now, if you look at the numerator, doesn't the numerator look a lot like a product rule? So you got two rules going on at the same time in this problem. So what we're going to do, when we do the derivative g prime of x, again, we're going to set it up in the quotient rule to begin with, which is bottom, derivative of top, minus top times derivative bottom over bottom squared. Okay, so let's go ahead and set it up. So we're going to start by writing down, oh, hold on, I see something really good on this one. Did you guys see what I see? I want you to look at the original problem. I want you to think about something for a minute. Do you see anything that, any way I could simplify that before I do the derivative? Yeah, I mean, look for stuff like that. I didn't see that, but so let's go ahead and let's simplify this thing first. So you can actually factor, and it won't change the derivative in any way. So you can actually factor out the 3 out of the bottom. So you'd have that, then it would cancel out, and then you would have e to the 2x over 3 like that, okay? Now, I would much rather do that derivative than use the quotient rule, wouldn't you? Okay, so here's the idea, and you probably ought to write this like this. Think of this as 1/3 times e to the 2x like that. Okay, so you can simplify before you do a derivative. There's nothing wrong with doing that. You're going to find this derivative isn't going to exist at x plus 1 because you're going to be discontinuous at x equals -1. But now when we do the derivative, this is what we just learned how to do. So what do? We just write down the constant, then we multiply by the derivative of e to the 2x. So what is the derivative of e to the 2x? 2e to the 2x, good. So that's 1/3 times 2e to the 2x. Now, if you multiply those fractions straight across, you're going to get 2/3 e to the 2x like that. That's actually a good example because you would get the same answer on that if you went through and did the quotient rule, but it would be a lot more complicated. It would be a lot more work. So what you want to learn from that is if you can simplify, by all means simplify, then do a derivative. Okay, it'll make it a little bit simpler for you. Okay. Okay, let's do this now. Now, if I say f double prime of x, what is that asking you to do? Second derivative. So we're going to do two derivatives on this. So to do part A, when we do the first derivative, what kind of rule do I have to use? Product rule. So the product rule is the one that goes first times derivative of second plus second times derivative of first. Okay, like that. So let's put this in. So we're going to write down just the first, don't touch it, times the derivative of the second. And let's write it down and kind of prepare to do a derivative rather than skipping a step. Then write the second, which is e to the 3x, times the derivative of the first. Okay? So first, derivative of second, plus second, times derivative of first. Okay, like that. And then we need to clean this up as much as we can before we move on and find the second derivative. Okay, so if you can simplify it, it'll help you before you find the second derivative. So this is going to be f prime of x equals x the third. So what's the derivative of this thing that I just circled in your head? 3e to the 3x. Good. Okay. Now, what is the derivative of x the third? 3x the second. Okay, now if you do this derivative, I want you to look for what you could factor on this. I mean, it's okay to write your derivative like that. I mean, you could clean it up a little bit. I'm going to do this in 2 steps. The best way to write this part right here is 3x to the third e to the 3x. And then this part would be best written as 3x the second e to the 3x. It doesn't really matter what order you put things in, but that would be a valid answer to the problem. That would be. Now, but I want to get you prepared for things we're going to do later. Do you see any common factors in this problem? You have a 3, right? What else? You have an e to the 3x, but there is one other thing. X squared, right. Remember, if you have x to the third and x to the second, what do? You take the one with the lowest exponent out. So your common factor is 3x to the second e to the 3x. And then you want to go through, and then you can write what's left over like that. Okay? So if we do that, okay, just think about what do you multiply this by to get this? We already got the 3. We already got the e to the 3x. We've got to multiply it by x, right? Because x to the second times x is x to the third. What do you multiply this by to get this? 1. Okay, that is the perfect way to write that first derivative. It's nice and simple and factored. You don't technically have to do that, but I'm just trying to get you comfortable with that idea. Okay? All right, now we're going to go on to part B, and I'm going to actually use this form when I do the second derivative. I just wanted to show you how that one factored. So now we're going to do the second derivative. And the second derivative is going to go like this. Okay, now we actually have to do this in 2 parts. So you actually have to do a product rule 2 times. So you have to use a product rule on that, and you have to use a product rule on the second part like this. So what you got to do is 2 product rules and add the result. Okay? May look intimidating, but trust me, it's not. So let's start that off and see what we get. Okay, when we do this piece, what you really do is you can just write down the 3. It's a constant, and I'm going to write a bracket, and then we're going to do the product rule of those 2 things right there. Okay, we have to. Okay, that's a product rule because it's a product of 2 functions. The 3 is a constant, just write it down. Okay, so let's do this. This time, let's kind of do a little bit of this in our head. You write down the first, which is x to the third. Then you multiply by the derivative of the second. So in your head, what's the derivative of e to the 3x? 3e to the 3x. Okay? Plus, now you do it backwards. Write the second, which is e to the 3x. And then what's the derivative of x to the third? 3x to the second, right? So that's what that derivative is. Of course, we're going to have to clean it up, but that's the idea. I wrote the constant down, and you have to have brackets because that 3 is going to multiply by the result of that derivative. Okay? Now, if you take the one that I highlighted in blue, it's done in a similar way. That's a constant 3. Write it down. Write a set of brackets. Okay? And then do the derivative. Okay? Carefully. The first is x to the second. Okay? What is the derivative again of the second? E to the 3x, what's its derivative? 3e to the 3x. Now do it backwards. Plus the second, e to the 3x times, and then what's the derivative of x to the second? What? 2x. Okay, got to bring the 2 down like that. Okay? So that's 2 product rules. So again, so you get into some big messy expressions in calculus. So again, what I'm doing is first derivative of second plus second times derivative of first. And I do that second one exactly the same way. So does that look okay? Okay. Now let's clean it up and see what happens to all this stuff. So I would suggest that we probably in this case just multiply all this out. Let's just do this in several steps. So bring down the 3 and write this as 3x to the third times e to the 3x. And then write this as 3x to the second times e to the 3x. And then write this as 3 times 3 x to the second, e to the 3x. Write this part down as 2x e to the 3x like that. Okay, and there's a tendency students want to stop there, and you don't want to stop there. You can go through and do a lot more things. So one thing you could do is you could multiply it out, and you're going to probably have possibly some like terms. So let's just do it like this. So that would be 9x to the third e to the 3x. And then 3 times 3, that would be 9x to the second e to the 3x. And then this would be 9x to the second e to the 3x there. And then plus 6x e to the 3x like that. Okay, I'm just doing that. Do you see any like terms? Is there anything that's exactly the same? Aren't these exactly the same? So that means you have 18 of those. And you could leave this in a non-factored form. You could say 9x to the third, e to the 3x, plus, that would now be 18, x to the second, e to the 3x, plus 6x, e to the 3x, like that. Okay? Now, you could stop there if you wanted to, or you could factor. There's a lot of things that could be factored out of that, so you can also do that. I'm not going to factor on all of these things. I'm going to go ahead and do this one because it is something that helps you for things we do later. What do you see as a common factor on this expression? 3, right? What else? X, what else? E to the 3x, right. Okay, the number that goes into 6, 18, and 9 is 3. Lowest exponent on these things, okay, that's x. They all have an e to the 3x in them, like this. Another thing is you're going to do factoring. It's a little more complicated than you did in an algebra class. So just do this in your head. 3 times 3 gives 9. What do you multiply x by to get x to the third? X to the second. Okay? Now move to the second term. 3 times 6 is 18. X times x is x to the second, or just x, sorry. 3 times 2 is 6. And that's it. Okay, like that. And again, if you factor something, be sure that you, at least in your head, multiply it out and see if it's right. So that is, now we've got the first derivative and we have the second derivative. Okay? So you guys are beginning to see what kind of algebra you get into, correct? Okay? This is what happens in calculus, okay? You get really strong with your algebra if you take the time to crunch these things out, and you're going to, when you do homework, you're going to make mistakes. It's part of the deal. It's part of the learning process, okay? All right, any question, anything I need to clarify on that? Okay, now I wouldn't ask you to do a 10th derivative on this, or probably not even a third derivative, but sometimes you end up, application-wise, most of the time you do a first and second derivative. We don't do much with derivatives in this class beyond a second derivative, okay? All right, so let's go to this next page, and then we're going to start into the trigonometry a little bit here today as well. Okay, now this one is the textbook. I haven't seen this kind of problem much in textbooks, but it's actually a very good problem because it tests to see if a student understands the product and quotient real well. So on this one, what they're doing is they're giving you the function values of f of x. All this means is like f of 1 is 5, f of 2 is 4. And then this second row is giving you the values of the derivative. The third row is giving you the function values of g, and the fourth row is given the values of the derivative. So if you're going to do this problem, you only have one way to do this. You don't even know what the functions are, but does that look like a product rule or a quotient rule? It's a product rule. So what you're going to do is you're basically going to do this. You're going to do the first times the derivative of the second plus the second times derivative of first, and then you're going to evaluate. Now, a lot of times in calculus, we write this evaluation like that. All that means is you need to go through now and you need to plug in x equals 1 into that function. Okay, now what we actually need to do in this problem is we need to figure out what f of 1 is. So I'm going to go ahead and write one more step and just write this as replace all the x's with 1. So we got f of 1 times g prime of 1 plus g of 1 times f prime of 1, like that. Now it's just a matter now of going to your table. Okay, so locate what f of 1 is. What is f of 1 based on this table? It's what? 5? Okay, sorry, I can't hear good. Okay, so that's 5. What's g prime of 1? 2. Okay, so we're going to have in here, f prime of 1 is 5. G prime of 1 is 2. Okay, what is g of 1? 4. Okay, so that's going to be 4. And what is f prime of 1? 3. Okay, so then to work this out, you would have 10 plus 12, so that would be 22. This is a exercise that just it sees if you understand how the product rule works. That's all that is. So it's kind of, you don't have to know what the function is. You could certainly find that derivative if you knew values without knowing the rule for the function. Oh, 22. Okay, so look at that. I can do everything except the last stage. There we go. 22 is better. Okay. All right, how about the next problem? What would you do? This is quotient rule, right? Okay, so what you want to do on this one is apply the quotient rule. So the quotient rule goes bottom times derivative of top minus top times derivative of bottom. And what's the bottom again on the quotient rule? Bottom squared. Okay, you got to square your bottom. That kind of sounds funny. X equals 2. Okay, so don't forget to square your bottom. Okay, now it's just a matter of evaluating all these things at 2 now. Okay, so let me kind of slide this down so we can see the table. Okay, so what we're going to do is g of 2 times f prime of 2 minus f of 2 times g prime of 2 all over g of 2 to the second power. So now it just becomes nothing more than really an arithmetic problem. And you want to go to your table now and just identify everything, okay? So it looks like g of 2, if you look at, we're really looking at this second column right here. G of 2 is going to be 2, so that plugs in like that. F prime of 2 is going to be 5. Then f of 2 is going to be 4. G prime of 2 is going to be, hold on, yeah, there we go. G prime of 2 is going to be 4. And then G of 2 was 2, so we have to square that. So that looks like that would be the arithmetic that we got to work out, okay? So it looks like we have 2 times 5 minus 4 times 4 over 2 squared. So that's going to be 10 minus 16 over 4. So that looks like negative 6 over 4. So that looks like negative 3/2 would be the arithmetic answer to that problem, like that, okay? Okay, that's not too hard. That's not as hard as taking an algebraic function and working out, because it's translated a little bit more into arithmetic then, okay?